In this activity, you will use your robot in a new mode. The robot will work on its own and will not be controlled from the switch controller. We have a special name for this way of working. We call the robot an autonomous robot. Autonomous means that the robot must work independently and think for itself. It is not controlled directly by the user. Today you're going to work out how to get your robot to go in a straight line. The robot has two motors that make the wheels turn so that they can drive about the floor. However, the motors are not exactly identical. Small differences cause one wheel to turn a little faster than the other, making the robot curve to the left or curve to the right. To get the wheels to turn at the same speed, you will need to get the robot to adjust the speed of one wheel so that the two wheel speeds are identical. We do this by setting pot 2. To work out where to set the pot, you need to do some experiments. Your first task is to mark out a straight line using black tape. This can be done on a desk or on the floor and will provide a straight line guide. If you're working on a desk, the line should be about 60 centimeters long. If you're working on the floor, then it should be about 120 centimeters. There are 3 pots, but initially you will only change pot 2. Pot 1 and pot 3 should be set to fixed positions. Pot 1 should be set to the 12 o'clock position, pointing to the battery. If you are working on a desk, set pot 3 to its 9 o'clock position. If you are working on the floor, then set it to the 12 o'clock position. As we have said, pot 2 adjusts the speed of one wheel compared to the other. Your challenge is to work out where pot 2 should be set to get your robot to go forward in a straight line. OK, you will need to get your robot into mode A0. To get there, do the following. Now power on. Robot will beep and should display the message Robot. The light below switch A will flash, and since it's the only flashing light, that is the only switch you can press, therefore press switch A. The display will change to an R with a flashing 0. We don't want mode R0, so press switch D and the display will change to an R with a flashing 1. A flashing display is the robot asking you whether you want this mode. Press switch A to accept this mode. The display will now show an A with a flashing 0. We want to accept this mode, so press switch A. The display stops flashing and shows A0. So the sequence was power on, press switch A, switch D, then switch A twice. As you know by now, if you make a mistake, just switch off and start again. The flashing lights now show that there are 3 switches that can be pressed. Pressing switch A will cause the robot to move forward. Pressing switch B instructs the robot's computer to read and remember the 3 pot values. Pressing switch C will exit from this mode. Put your robot at the start of the black line like this. Let's start the experiment. The worksheet has a summary of the experiment and a table to record your results. First set pot 2 to its 10 o'clock position. Now press switch B to get the robot to read and remember the pot values. Then press switch A to start. Observe the way the robot moves and mark the point where the robot stops. Our robot veered to the left, so we should put this symbol in our table. Now adjust pot 2 to the next position as shown on your worksheet. Press switch B to input this setting to the robot and line up your robot as before. Press switch A to run. Repeat until you have filled out the table. When it is complete, you should be able to work out what the pot 2 setting should be to make the robot go in a straight line. Try it out, and if the robot moves forward in a straight line, draw the arrow position for pot 2 in this circle. Once you've filled out your table and worked out how to get your robot to go in a straight line, you're ready to experiment with pots 1 and 3. Pot 1 varies the speed, and pot 3 varies the amount of time the robot drives forward. Understanding what effects these pots have will help you in the next activity, 10-pin bowling.